Hi everyone, here's our math problem for today. We begin with 2019 and raise it to exponent 2018 and continue raising it to an integer that is 1 less than the previous exponent until we arrive at exponent 3, exponent 2, and exponent 1. We know that when we expand this exponential number, the result would be certain digits, but we are only interested with the last digit. We want to know what is the last digit of this exponential number when evaluated. You can pause the video and see if you can solve this math problem. Now let's solve this problem together. There are 3 steps and 3 key concepts that we are going to use. First one is this one. The last digit of a certain number in exponential form m raised to n can be computed by raising the last digit of m to exponent n. For example, if our m is 217 and we raise this to certain exponent, let's say exponent 3, the result of this is 10,218,313. But since we are only interested with the last digit of this exponential number when evaluated, we do not want all these other digits except the number 3. And so computing for these other digits would be a waste of time. We want only the last digit. Notice that if instead of raising 217 to the third, we just take the last digit 7 and raise it to the same exponent 3, the result is 343. And notice now that their last digits are both equal to 3. That is what we mean by this key concept. Meaning, if you have 2019 raised to this so many exponents, the last digit of this exponential expression is just the same as the last digit when 9 is raised to the same exponent. We do not need to compute the entire 2019 raised to this exponent. If we want to find the last digit, we can achieve the same result by just taking the last digit 9 and raise it to the same exponent. And that already lessens our computational load. Second step, let's investigate the pattern of the powers of 9. Because we now have here 9, we want to know what's the pattern when 9 is raised to any exponents. So let's raise 9 to the first, 9 to the second, 9 to the third, 9 to the fourth, 9 to the fifth, 9 to the sixth, and by now, we have seen the pattern already. Notice that when the exponents are odd numbers, 1, 3, 5, the last digits are 9, 9, and 9. So, when the exponents are odd, the last digit is 9. When the exponents are even, 2, 4, 6, notice also that the last digits are all equal to 1. And so when the exponent is even, evaluating exponential expression would result to a number with 1 as the last digit. And so, finding the last digit of this exponential expression is now narrowed down to knowing what is the parity of the exponents of 9, whether these exponents resulted to an even number or an odd number. And that brings us to our third step. We want to know the pattern of the powers of 8 or the patterns of any even number for that matter. Why are we interested with the number 8? Notice that you have here 2018 raised to these exponents. As we have seen in our first step, the last digit of 2018 raised to this exponent is just the same as getting the last digit 8 and raising that to the same exponent. And so, let's see what's the pattern when 8 is raised to exponents. 8 to the first is 8, 8 to the second is 64, 8 to the third is 512, and so on and so forth. And so what's the pattern? No matter what the exponents are, when 8 is raised to any exponent, the resulting number are all even numbers. You have 8, 64, 512, 4096, and so on. These are all even numbers. So, we now know that this exponent is an even number. So we now have 9 raised to an even exponent. And going back to our second step, when the exponent is even, the last digit when 9 is raised to that exponent is equal to 1. And so, for our final answer, the last digit of this exponential number is equal to 1. Bye for now.